Right, today we supposed to start the limits and differentiation part. Today I completely finished the limits part. Corporal forces. First part of the corporal forces I finished completely next day, and thereafter I take differentiation 2 hours and corporal forces 2 hours, covering the first parts of the 2 lessons. Okay, right. So then today this is a pure maths lesson. Right, the heading is limits and differentiation. Is coming under calculus. Right. Limits and differentiation. Right. Okay. Let's discuss first what is limit. What is a limit? Okay. Now suppose on the number line, we have here 2. Right. Okay. Now here we have a variable x. X is a variable, a real number. Right. Suppose here we have 3. Now this x variable is coming from the right of 2 towards 2 this way. While it is coming from the right of 2, it takes values available on the number line. Suppose it takes first 3 and 2.9, 2.8, okay, 2.7 and so on, 2 point, right, this way, 0.1, 2.001, those values it takes, okay. Then those values, if I mark here, I am marking on the number line here. This is that value, suppose 2.9. Suppose this is the 2.8. These are the values now this x takes. Then you can very clearly see x takes value coming towards this 2 on the right of 2. Then this is written as x approaches to 2 on its right hand side. That we denote this way, plus sign. On the right of 2, x approaches to 2. Okay. The word approaches here we write as limit. X limit goes to 2 from the right of 2. But when you write the word limit also, we write only lim, lim. You see. Okay. So then this is limit of x going to 2 on the right of 2. What do you mean by that? X coming closer to 2, taking all the values available on the right hand side of 2. Understand? That means x takes these values. Understand? Here. People in this case remember x takes values which are close to 2 mean this x never take 2. X coming to this 2 from its right hand side, right? But this x never takes what is 2. Then this does not mean x equals 2. No. X going closer to this 2 as much as possible. What is the nearest number to this 2 on its right hand side? What is the nearest number? What is the nearest number to this 2 on this right hand side? No? No such number? Huh? What is the nearest number? Huh? Infinity? Nobody can say exactly the nearest number to this 2. If you say a nearest number to this 2, I'll give more nearest number than your number you said. Huh? Suppose x equals 2.0000001. Suppose your number which is nearest to 2 on its right hand side. I'm going to say another nearer number than this. How? I can put another 0 and 1 here. That is more nearer to this 2. So then x takes those numbers and x never take that 2. Therefore, remember this limit mean x going to 2 as much as possible. Okay, but x never takes 2. Right. Now suppose x coming from this end like this. 1. Okay. 1.1, 1.2, 1.3, and so on this way. Then how should we write that? Lim x approach to 2 on the left of 2. On the left of 2. Understand? That is how we write it. This also doesn't mean that x takes 2. Understand? Right. So now this way, x comes closer to this 2 from both sides of 2. This way. X coming to this 2 on the right hand side. It is written like this here. And x comes to this 2 on the left hand side of 2 like this. Okay. Once this both write together, this and this 2 we write together as lim x goes to 2. Understand? Then this single statement contains what? Both this. Right? Then this is called as right limit because x going to 2 on the right of 2. This is called as a left limit of 2. Okay. So once this both we need to write single statement, this is how we write it. So therefore in the single statement, this both available. Understand? Right. Now let's see why should we use this limit? Okay. Before going to that, I'll take another simple example. I take this way the y equals x square graph. Y equals x square graph like this here. This is the graph of y equals x square that we drew in quadratic equation lesson, no? Right. The equation of the graph is y equals x squared. Right. Suppose here we have x equals 2. X equals 2 here. At x equals 2, let us calculate the y. Y means this height, that means this height. That you can calculate directly, put in x equals 2 here. Then 2 squared, it is y equals 4. Right? Therefore, this is 4. Right. Now, I'm going to construct a table. In the table, in the first table, I supposed to put for x, those values coming to this 2 on its right hand side like this. And I supposed to find the corresponding y value. Okay. The second table, I am going to consider x values which are coming to 2 on the left of 2 this way. Then I am going to calculate the corresponding y values, right? Then in this table to fill, somebody help me. I'll give some x values. Substituting that x values here, give me this y value. Okay. First I put this way. I put 2.1. Okay. Next one 2.01. Next one 2.001. Those values I substitute for x. All right. Give me somebody, right? The corresponding values. Yes. First tell me when x is 2.1, what is x squared? 4.4, 2.1 squared, 4.41. Yes. 2.01, 4.0401. This is correct. Correct. Yeah. What's the next one? Zero, 4, 0, 1. All right. Now, can you see, once you very carefully observe this number, 2.1 is somewhere here. 2.01 is more closer to this 2. 2.001 is more closer than previous two values. Okay. Then you can see there y values. 4.41 is somewhere here. 4.04 are more closer to what 4 than earlier. That one here. Then you can see once this x goes to this 2, how to write this? Limit x approaches to 2 through greater values than 2. What can you say the y values? Y values are coming to what? 4. No? Y values are coming to 4. So here, y goes to 4 through values which are greater than 4. Yes. Second table, I feel like this. I put 1.9, 1.99, 1.999. Tell me here too. 3.661. This one? 3.9601. Next one? 996,001. Right, good. Now, you can see now, first x values, 1.9 is somewhere here. 99 is somewhere here. 999 means somewhere here. Then we know x going to do what? Limit x approaches to on the left of 2. What can you say about y values? Y values what? Increasing, no? Towards what? Towards 4. See here. This way it goes. Okay. Then how to write this? Limit y approaches to 4 through smaller value than 4. That's how we write. Then people, once this x comes to this 2 from both ends, we know these 2 together, we said we can write limit x approaches to 2. Okay. Once this 2, x comes to this 2 from both ends of 2, what has happened here? Y coming to 4 from both ends. Then I can write limit y approaches to 4. Okay. Then here we can write this and this together as lim x goes to 2. What do you mean by that lim? Limit means approaches, right? X approaches this 2 from both ends, right? We can write y approaches to 4, right? This y value to which that finally approach is nothing but when you directly substitute this 2 where here, okay, that value only here we get 4y. Okay, when you put x equals to in y equals x squared, okay, 2 squared is 4, y equals 4. This value only here people we get. Okay. Now I am going to tell you then what is the importance of using this limit. I can explain it like this. Instead of that graph y equals x squared, I take this graph, right? Okay, I take this graph. As here at x equals 2, if I need to find y value, I had 2 ways. First is directly I can substitute this x value here. We got the value 4. The same value only by this way preparing a table line, considering the limiting technique, we got here. These 2 values are equal. Okay. Now suppose I need the y value here when x equals 2. In this graph, when you draw this graph, we get a certain graph. At x equals 2, suppose I need y value. Then I first use this method, direct substitution method. Once I put x equals 2, see what happens. 2 squared minus 4 divided by 2 minus 2. 2 squared is 4, 4 minus 4 is 0, divided by 2 minus 2 is 0. What is 0 by 0? 1 no, 0, infinity. What is 0 by 0? 1, 0, infinity. Undefined. It is undefined. This is undefined. In maths, we can't give any value for this. Undefined. Meaningless. Indeterminate form. People in mathematics, there are 7 indeterminate forms. 0, 0, 0 by 0. Okay. Infinity by infinity. Infinity minus infinity. 0 multiplied by infinity. 1 to the power infinity. Right? 0 to the power 0. How many now? 3, 4, 5, 6. Another one. There are 7 indeterminate forms. If we get for any simplification, one of these answers by the direct substitution of that x value, right? We can't find out here now. Okay, y value when x equals to, you can't find, no? But when you sketch this graph, you will see by the graph, y value means people at x equals to, from x-axis to this graph, this height. This height only, the y value when x equals 2. When you sketch this graph at x equals 2, you can see there's a certain height. That height only we are supposed to find this way, but we can't find that, we get undefined form. Now in this case, I roughly draw this graph. I'll explain how do we draw this one. Right, the graph coming like this. X equals 2, there is no point on the graph. This is the graph. It's a straight line. This is a straight line. Okay. This is a straight line. Okay. You know, how do we, even though we draw the graph like this very easily by moving our point of pen or pencil, really the graph is formed how? It is formed with infinitely many points closely situated each other. Understand? How do you form a point? For x value, we have to find y value. The corresponding place, we have to put a point. Understand? The point we denote by a dot. So that means people, really, when we draw this graph, right, put in x value 1, for example, we have to find y. When x equals 1, we have y some value. Then at that point, we have to put a dot like this. Line is infinitely many dots, right? When you keep people, that is how this line is formed, right? See, once you prepare this way, arrange this way, infinitely many points, the line is coming. That's the actual way of drawing the line. But once we do like this, one occasion we put x equals 2 to find y value. Y value is what? Undefined. Then when x equals 2, can you find a position to put that point? No. Then we have to skip that. We have to skip that x equals 2. We can't find y value because 0 by 0 undefined. That occasion, we can't find exact what location to put that point. That point only missing here. Understand? Right? Then you can see this way, if I take one point away, what happens? At that point, the entire graph breaks. Entire graph breaks. Understand? That kind of graph is called as discontinuous graph. Discontinuous graph. Understand? But now you can see people, we try to find this y value when x equals 2. Directly substituting for x equals 2, we got 0 by 0. We tried to find this height. Okay, this height. You can very clearly see by the diagram there is a height. But we can't find that height by putting x equals 2 here. But obviously we can see there's a height. Now to find this height only, this technique we can use. Now what we do? These x values, we substitute here. And this column we fill. This x values, we put here. And we fill this column. By observing the behavior of this y value, finally you get certain idea about this, no? Understand? So now can you understand what importance this limit has? Then tell me what occasions we must use this limit. When a graph is discontinuous at certain x value, at that x value, if we need to find y value, obviously once you substitute that x value directly in the right-hand side of the function, we get one of these indeterminate forms. In that case, when our answer is one of these, we can't give any value there. They are called as indeterminate forms. That occasion, if we need to find that y value, we use what this limit techniques. What we do there? From right of 2 and left of 2, we approach to 2 from both ends. And we find this way, what are the possible y values? By observing these possible y values, we can determine what is this height. Understand? What is this height? Okay, therefore, remember, for that purpose only, we use this limit. Now, is it clear? Why should we have the knowledge of limit? For this purpose only, people, we use the limiting technique. Yes. Now, you might ask now, in this case, really, if we need to find this height, okay, by preparing this say a table, do we need to work out everything? No. No. These tables, of course, no longer we prepare, right? We do it like this. Here, we need to find this height, no? When x equals 2. When x equals 2, this height we need to find. But x equals 2, direct substitute gives indeterminate form. Then we come to closer to this 2 from both ends. That means we must take this, no? Okay. I told you limit x going to 2 means what? 2 what things? What are the 2 things? This says x coming to 2 on the right of 2 and left of 2. Okay. Then we need to find as x going to 2 the value of this, right? This x squared minus 4, right? Divided by x minus 2. Right. Now we can factorize this. X plus 2, x minus 2. Right? And here we have this way, right? This 2 you can cancel down. Now what do we have? This. Okay? Now see here. X going to 2. X going to 2 doesn't mean x takes 2. Then x going to 2 means what? X coming closer to this 2 as much as possible from both ends. Once that x value put here, x plus 2 will be going to what? X plus 2 will be going to 4, no? Reason? Put for this x 1.99 because x going to 2 means 1.99 possible, no? 1.99 plus 2 is what? 3.99. Put for this x 1.999. This is now 3.999. Therefore, to get this answer, directly put this 2 here, then we get 2 plus 2 is 4, no? Then we say what? This whole expression, we write what? Going to 4. Understand? So, therefore, finally we write like this here. As x going to 2, this way, x squared minus 4 divided by x minus 2, that goes to 4. This is how we write. Understand? This expression as x going to 2, this x squared minus 4 divided by x minus 2 goes to 4. This way we have to put an arrow. Right? Why? It doesn't take 4. It goes to 4. Understand? Goes to 4 and doesn't take 4. As much as possible goes to 4. Coming closer to 4. But people, in real mathematical world, in place of this arrow, we put what? Equal sign. Right? Equal sign for our convenience. But actual situation should be what? It goes to 4. Understand? It goes to 4. Right? Okay. This story, of course, usually we can explain. Right? Now, at x equals to y value, this way we get indeterminate form. But there is really what? Y value. We need to find that. For that purpose, we come to this 2 from both ends. This is example, of course, we can really explain like this. I take this example every year. Okay. Now this way, there's a very beautiful girl. And there's another boy. Okay. This boy need to touch this girl. But we know boys can't touch the girls like this, no? Reason, sometimes the result may be bad. But even though this boy need to touch this girl. But the boy has a hesitant mind, what? What will happen to me once I touch her? That also this boy need to know in advance. Understand? Then, first of all, this boy tries to know what happens if I touch her. By knowing that result on the second occasion, he is supposed to do what he need to do. For this purpose, in order to carry out that, this boy going closer to this girl by studying this girl, so that he gives the idea to this girl, next moment I will touch you. Giving that feeling, the boy going closer to this girl. Meantime, this boy study the behavior of girl. If the girl is like this, boy knows what? Boy knows what? Little bit okay. Once the boy going closer to this girl, if the girl going down and taking something, boy knows situation is dangerous. Something like that only people under this limit we supposed to do. We come in closer to from both ends, and by studying that we take the idea about this. අයි අපිට එහෙම කරන්න වෙන්නේ කෙලින්ම කරොත් වෙන දේ ගැන හිතා ගන්න බෑ. මම කිව්ව දේ හරිය නේද? අපි voice ලත් එහෙමනේ. එහෙම නෙමෙයිද? එහෙමනේ. පොඩි approach එකක් දීලා බලනවා. response හොඳයි නම් continue කරනවා. bad නම් වෙන එකක් හොයාගන්න. Right. Then people remember, we need this limiting idea at what locations? When the graph is discontinuous at certain x value, to find this y value, direct substitution gives us intermediate form. That location, by going to that x value from both ends, we find possible value of y. That kind of thing only on this limit we do. Okay, right. So that is the overall summary in the lesson. Now, after this, we take a note and we try to do some different types of questions to finish what limit today. Right, okay. We'll take down to if not. Right, write down subordinates limit. Write down like this. Consider a variable simple x. Consider a variable simple x takes the values on either sides of 2 on the real number line. On the real number line. Right. First, we can write these numbers this way, right? This is 2.1, 2.01, 2.001, 2.0001. 1.9 here, 1.99, 1.999, and here is 1.999. How do we write this? This we write how? X limit approaches to 2 through greater values than 2. We put plus sign here. Through greater values than 2, like this. This we write here. What? Lim x approaches to 2 through smaller value than 2, like this. Through smaller value than 2. On the left of 2. Okay. This is called as what? Right limit of x. This is called as left limit of x. Okay. Then this both, how do we write? Simply write in one statement, right? Lim x approaches to 2 plus, lim x approaches to minus. Both we write together as lim x approach 2. Right now? Yes. Right on there. Right. Now write down next line. Now consider the graph of y equals x squared. You know the graph of y equals x squared. You see, we have that. I'll take here x equals 2. Draw this one, we'll write one sentence there. Right now? Now write down like this. The y value of the graph, the y value of the graph, the y value of the graph when x is 2, when x is 2, can be calculated substituting x equals 2, substituting x equals 2 for x in y equals x squared, for x in y equals x squared. And then y equals 2 squared, 2 squared is 4, y equals 4. This is 4. Right. Right. Now, people, why do like this here? Somewhere here, x value, I put in this y equals x squared. Corresponding y value, I can very easily find by this graph itself here. We draw vertical line like this until it meets the graph. From here, we draw horizontal line until it meets the y-axis like this. Now another closer value we put here. Right? Now mark this 2. Right? Another closer value to this 2. I put like this here. Okay. Then this x going towards what? 2, no? From the right. Then what can we say here? Y values come into 4 from up. Okay. Then how do you write? As x goes to 2, x limit 2 plus, y limit 4 plus. Understand? Okay. Mark them here too. Right? This you can write lim y going 4 plus. This you can write lim y going 4 minus. This you can write lim x 2 plus. This you can write lim x 2 minus. Okay. Mark them. Yes. People, you know, these two together, how do you write? Lim x approaches to 2, no? Lim x 2. These two together we can write lim y 4. Understand? Okay. Now write down like this. By the diagram, after finishing this, write down. By the diagram, by the diagram, as lim x 2. This means what? X coming to 2 from both ends, huh? Right. We can see lim y approaches to 4. Correct, no? It comes to what? From this end, it goes to 4. This way goes to 4. Right? The most important thing is, people, this number only here we get. Okay? Right, no? Yes. This number only here we get. Right. Right. I don't like this. Now consider the graph y equals x squared minus 4 divided by x minus 2. Write down like this. Let's find the y value of the graph. Let's find the y value of the graph when x equals 2. Substitute x equals 2. Put in x equals 2. Y equals 2 squared minus 4 divided by 2 minus 2. Y numerator 0, denominator 0. 0 divided by 0. What? This is undefined, indeterminate form. We need this. Undefined. Undefined. Nobody can give an answer for this. Or indeterminate form. There are 7 indeterminate forms. Okay. But the exit graph has. Now, to find that, here, we stole this value only for this graph we need to find. But it gives undefined form. But we have the same value we get here by using the limit technique. Therefore, direct substitution in this, though we get this undefined form, the same answer we can get by using what? This limit. Understand? Now we try through what? Limiting technique to get this height. Okay, that's the use of limit in our mathematical verbs. Okay, right. Undefined. Right on. Now let's use. Right on. Now let's use a limit technique. A limit technique to find the possible y value of the graph y equals x squared minus 4 divided by x minus 2 at x equals 2. Right. We take like this. Y equals, we take on the right hand side limit x approaches to 2. Limit x approaches 2. That means x going to 2 from both ends. Right. This now. Right. Now we factorize the bracket. X minus 2, x plus 2. X minus 2. Okay. Now cancel down like this. This 2. Y. With x going to 2. 2. Okay. Now, this x going to 2, gradually this place will be coming with the values close to 2, no? 1, well, when we put 1.9, 1.9 plus 2 is 3.9. Then when x goes to 2, this figure goes to what? 4, no? 4. Goes to 4, no? Understand? Yes. Then we know it goes to 4. Then we can't put in equal sign there, no? Then we must write what? For this equal sign, we have to put what? Arrow. It goes to 4. Understand? But even though we put equal sign here, remember there, that equal sign in this case, we have to approximate that going to 4. Then here, that height is going to 4. Going to 4. The height is going to 4. Right? Not exactly 4, going to 4. Understand? That's sufficient, no? Height is going to 4. Not exactly 4, going to 4, remember. Therefore, remember here, we put 2 here. Then you might ask, x going to 2 doesn't mean that x takes 2, no? Correct. I agree with you. I put 2 here, then 2 plus 2 is 4. But I supposed to write this going to 4 putting arrow. Correct? No? 1.9, 1.99, 1.999, so on when you put at these places. But this sum is going towards 4, no? To that easy way, this x we replace by 2 and then 2 and 2 we write as 4. Then I write y going to 4. Correct? No? Y going to 4. This is the actual way of writing. But for our convenience in our day-to-day mathematical works, in place of this arrow, we do that error, what? Y equals 4. Still we get marks there. But remember there, that should be what? Written as not using equal sign, that should be using an arrow saying that goes to 4. Understand? Therefore, hereinafter people, when you need to evaluate the limiting value, this x value here, directly put here and find the sum. Then we must write y going to 4 like this. But we write this arrow replacing by equal sign. Okay. Then other thing here, this way when we directly put x equals 2, we got undefined form, no? Right. By using the limit technique, if you need to evaluate this y value, always here, suppose this arrow like equal sign and take this 2 to this left hand side. Suppose this arrow is an equal sign. Take this 2 to this left hand side. What do you get? X minus 2, no? Yes. People remember, until you cut x minus 2 from numerator and denominator, don't substitute this 2 for x. Understand? Until you cancel down, now once you take this 2 to this side, we get x minus 2, no? That x minus 2 factor, until you cut down from numerator and denominator, don't substitute x equals 2 for x's. Before cancelling like that, if you put x equals 2, you get what? Undefined form. So therefore, the place where you have to put that x equals 2 should be what? Soon after cancelling the factor x minus 2 from numerator and denominator, after that any stage put what? X2, then you get the limiting value. That's the technique of getting the limiting value. Understand? Until then, don't put. Okay? Then this we write how y going to 4. Right? Write down like this. Y limit going to 4. Okay? This is the correct way of writing that. But we write this as how y 4 putting equal sign. Doesn't matter, you get marks for this. Right? Therefore, y equals 4. This is how we evaluate. Write down these indeterminate forms. Undefined forms, so indeterminate forms. There are 7 forms. First one, like this 0.0, infinity by infinity, infinity minus infinity, 0 to the power 0, 1 to the power infinity, infinity to the power 0, 0 multiplied by infinity. There are 7 forms. 1, 2, 3, 4, 5, 6, 7. If you get one of these answers, that is called as indeterminate forms. You must use limit. Right now, yes. Now we'll come to questions. Right, we'll write some questions. Today you don't have the tutorial. Next week you will get the tutorial. Write down these questions. Number 2. Yes, right. Okay, we'll first find this. Yes, I'll take the first one. What is the people technique of getting the answer? Once you take this 2 to this side, we assume that as x minus 2. Until x minus 2 cancel in from numerator and denominator, don't substitute x equals 2. Right. Soon after cancelling, put that. Then we get the limiting value. Right. Okay. First one. Limit x approaches to 2. Oh, limit x going to 2. X squared minus 3x plus 2. X squared plus x minus 6. So in this case, in order to cancel down x minus 2, both the numerator and denominator must have the factor x minus 2. How do you check that x minus 2 is a factor of this and this? Substitute x equals to n, see whether this is 0. When you put x equals to n, if this and this both 0, according to converse of the factor theorem, you know x minus 2 is a factor. Can you remember the converse of the factor theorem? Yes. You know, when you put x equals to here, what do you get? 4, 2, 6. Here 2 minus 6. 6 minus 6 is 0. That means x minus 2 is a factor, no? Yeah. Here also, when you put x equals to 4, 2, 6, 6 minus 6, 0. Then both this and this have what? X minus 2 as factors. Then factorize that and cancel down. Then put that. X minus 2. What should be the next one? X minus 1, no? Correct? No, then 3x coming. Here, x minus 2 and x plus 3. Right, no? These two we can cancel down. Now we have limit x going to 2, x minus 1 now, x plus 3. Right? Now substitute for what? X. This value 2. What do you get? 2 minus 1, 2 plus 3. What do you get? 1 upon 5. Then really, is it okay to put this equal sign? No. We have to put what? Arrow. Understand? It goes to 1 upon 5. But we write this as 1 upon 5, you get full marks. Concept identifier, understand, this equal sign is really not valid. That goes. But we write like that. Yes. Like that, do the second and third. Second one. You see, we can factorize the denominator. No, one factor you know as definitely x minus 1 should be one factor, right? Then here plus 5 come in, minus 2x, minus 5x, minus 7x come in, right? No? Now you should be able to factorize like this, right? So no need to use the OL technique, right? In that end, you see, you can cancel down now. Now take limit x going to 1. 1 over 2x minus 5. Put x equals 1 here. Minus 1/3. Minus 1/3. Come to this third one. X times x squared minus 5x plus 6. Okay, what factor we must be able to cancel down? X minus 3 factor should be cancelled down. Until then, don't put x equals 3. Okay, right. So I can write like this. Limit x approaches to 3, x going to 3, 1 over x minus 3, 3 over here. You can factorize this. X minus 5x plus 6, I can write x minus 2, x minus 3, no? This way you can factorize that. Then this 1 over x minus 3 factor, you can take out like this. Can take x minus 3 out like this. Open a bracket now. Here we have now 1 minus 3 upon x times x minus 2. This way. Now take here common denominator. What do we get there? X times x minus 2, common denominator, right? That comes here, no? X times x minus 2 minus 3. This way. Now you can write. What is this? Numerator. X squared minus 2x minus 3. Factorize this numerator. What do you get? X minus 3, what? X plus 1. X times x minus 2. Now only we can cancel down this ends. The next line substitute for x is 1. Next line substitute x equals 1. So I'm not going to write another one more step after cancelling this one. Earlier examples, I wrote the remaining term with this limit. And after that, we put 3, the x value. Now I substitute directly and take the answer to save another one more step here. Once I put here 3, what do you get? 3 plus 1 is 4. 3 minus 2 is here 1, here 3. Then 4 by 3 coming. No? Yes, 4 by 3. Then we write the answer as 4 by 3. This way we keep the answer now. Right. Okay, right. We'll get the second set of questions. I'm going to discuss all different types of questions which may come here, right? Then today we can finish for limit part. Next day we start the cooperative forces. After that we do both differentiation and cooperative forces. At fourth example, this limit x going to 0, x approaches 0, in other words, root 2 minus 6 minus root 2 plus x divided by x. Fifth one, limit x going to 0. Root x minus 2 minus root 4 minus 6, like this. Number 6, limit x going to 0, root 1 plus x minus root 1 minus 6. This 3. People now in any question here, when you directly substitute this x value for every x in the function, definitely you get what? Certain undefined form, indeterminate form. For example, here, put x equals 0 here 0, root 2. Here 0, root 2. Root 2 minus root 2 is numerator 0. X going 0 now is also 0. We get what? 0 by 0, undefined form. Okay. Now we'll see here how to do. People, now in this case, when you evaluate this limiting value, once you bring this 0 this side, x minus 0, x no. Then until what factor we cancel, we should not put 0. X minus 0 is x no. Until x cancelled from numerator and denominator, don't put 0 for x. Understand? Okay. Then in this case, to evaluate this is the technique. Limit x tends to 0, right? Here, root 2 minus 6, root 2 plus 6, divide by x, no? Right. Now we multiply this by the conjugate of the numerator. Conjugate, right? The word is, remember, conjugate. Conjugate is defined like this. If we have an expression x minus y, its conjugate is obtained by changing the middle sign to opposite, x plus y. If the original expression is x plus y, its conjugate is x minus y. So, the conjugate of this numerator is what? This plus this. By that conjugate, we multiply both numerator and denominator. Understand? We know when we multiply both numerator and denominator by same value, the fraction won't change. Okay? Then multiply numerator and denominator both by the conjugate of this. Okay? Right. Like this. Now people, here, numerator, it is now what form? Yes. If you take this as A, this as B, here we have A minus B, here we have A plus B. A minus B into A plus B form, we get, what is that? It is A squared minus B squared. A squared means what? Square of this. The root will eliminate 2 minus x. Minus B squared means root will eliminate 2 plus x. Understand? There we form what? Factors of difference of two squares. Understand? To form that only we multiply by the conjugate. Right now? Yes. You get 2 minus 6 here. Minus 2 plus 6. X times 2 minus 6 plus 2 plus 6. Okay. Now this numerator, once you remove the bracket, here we get minus 2, and this plus 2 you can cancel out like this. Here we get what? Minus x. Here we have minus 6. Minus 6 minus 6 is minus 2x. Correct, no? Minus 2x. Minus 2x upon x times root 2 minus 6 plus root 2 plus 6. Okay. Now cancel down this x and this x. Right. Until the cancellation like this x from numerator and denominator, don't put 0 for x. Now put 0 for every x. No need to write another one more step there. I'll write directly 0 here and here. Numerator minus 2. Here 0 put root 2 plus put 0 here root 2. Then what we get? 1 over root 2. No, minus 1 over root 2. No, why? Root 2 and 2 root 2 means 2 times root 2. 2 and 2 you can cancel down. Minus 1 over root 2. Answer is this. Right. People, in the same way, you can do this as homework. Number 2. What is the method there? Multiply numerator and this denominator both by the conjugate of denominator, no? By the conjugate of denominator. Right. Do that as homework. Come to third one. Third one. Limit x approaches to 0. Right. This way we have root 1 plus 6 minus root 1 minus 6 divided by root 2 plus 3x minus root 2 minus 3x. Right. So this time, how do you work out? What factor we should cancel down before putting x0? X factor. Then this is how we do, people. Both numerator and denominator, first I multiply by the numerator. That means what? This plus this. By that we multiply numerator and denominator. Secondly, again numerator and denominator we multiply by the conjugate of this. Understand? Long expression coming. Yes. Okay. Then I am writing like that. This, no? Yeah. So first I multiply this by its conjugate. This way I write 1 plus x root plus this. All right. By the same, we must multiply denominator. I write that here. Root 1 plus x plus root 1 minus x. This way. Now, by the conjugate of denominator, again we have to multiply both numerator and denominator like this. Root 2 plus 3x plus root 2 minus 3x. Right. Now, this can write how? A minus B into A plus B, no? What's that? A squared minus B squared, no? Yes. Okay, of this, root will eliminate 1 plus 6 minus 1 minus 6. That part will remain there. 2 plus 3x plus root 2 minus 3x like this, huh? And here, this 2 again, square of this minus square of this. 2 plus 3x minus 2 minus 3x. And here it is root 1 plus 6 plus root 1 minus 6. Limit x going to 0. Now simplify this. Here this minus and this one is minus 1, that you can cancel on with this. Minus minus plus x, this is now 2x, huh? Right. Here we have minus 2 plus 2, you can cancel down. Minus minus plus 3x plus 3x is, this is 6x now, right? Right? Okay. Now, you can now cancel down this 1x here with this. Also, 2 and 6 also we can cancel down like this 3. Right? Okay. Now we have cancelled down x from numerator and denominator. Now this is the time to put x0. Understood? No need to write another one more step there. We'll write what x0 at these places. Here we have 3, right? What do you get here? When you put x0, 3 into 0 is 0, root 2 plus root 2, 2 root 2. Here 0, here 0. Root 1 means 1. 1 plus 1, 2, no? Yes. Then we can write, they are root 2 divided by 3 times root 1 plus root 1 means 1 plus 1. What do you get there? Here root 2, 2 root 2, right? 2 root 2 divided by 3 into 2. This and this you can cancel down. We get what? Root 2 over 3. That's the answer. Right, no? Yes, right on this. Okay, we have another theorem, right? The proof of the theorem I supposed to do later, not now, right? Because once we take the time to prove that today, we can't come to the end of the limits part today. But anyway, those proofs I will discuss at the end of this lesson. You should know how to prove them. But in the past papers, when you go through, no any paper, the proof available asking in the past papers. But we should know that one as a student. I'll prove that later. Okay, today I do questions by just mentioning that theorem, right? Okay. Right. Then shall we write down the theorem? Did you finish? Right. This is the theorem, right? Right. or when n is a rational number. When n is a rational number, our limit x approaches to a, x to the power n minus a to the power n divided by x minus a. Yes. N a power n minus 1. This is the theorem. We can prove this. Right? What is rational number? In rational number means what? Those numbers we can write as a fraction. Are there numbers they can't be written as fractions? Yes. There are some numbers in real numbers. Those numbers we can't write as a fraction. Give me one example. The value, pi. Hmm? The area of a circle we wrote by this expression pi r squared, no? This pi, we write that as 22/7. But this is not the exact answer of this pi. What is this? Approximately the good fraction which gives the approximate answer for pi. This pi, its actual value, nobody can write by using a fraction. This fraction is not the actual fraction. It's an approximate fraction. So therefore, this pi is not a rational number. And also take root 3. Its value is 1.7321. So on. No. That also nobody can write as a what? Fraction. Root 2, root 7, and so on. There are many irrational numbers. These numbers are called as not rational. That means irrational numbers. But in this theorem, that n is a rational number. Right. Then try to understand the theorem. See here. Numerator, in between these two terms, we have minus sign. Xn, an available. When you delete this n power, we have x minus a that is at the denominator. When you ignore this n, we have x minus a that is at the denominator. Under this limit, x going to a, that means what? This should go to a. Okay. Now, identify the picture here. If we have this type of question, its limiting value going to be what? N a to the power n minus 1. What is this n? This power comes here, this a here, right? N comes before here, a, and new power of n is subtract 1 from this n. Understand? In this answer, I am going to tell you how to remember. Bring this in before this a, and then a, and new power write down subtracting 1 from this. That's how we get this answer. Okay. Therefore, identify the picture, right? Numerator, denominator, both should have in the middle minus sign. These two powers should be equal. Once you delete these powers, that should be the denominator. Under this limit, this should go to this. If you have a certain expression, its limiting value is what? N bring before a to the power, subtract 1 from this in minus 1. Understand? That's the answer. We can prove this one. We will prove this later. Today we'll do some questions, right? Okay, write down this. This is theorem. Right, write down these examples there. Question number 7. Limit x approaches to 2. X to the power 7 minus 128 divided by x minus 2. Number 8. X limit going to 2, x cube minus 8 divided by x squared minus 4. Number 9. Limit x approaches to minus 2. X power 5 plus 32 divided by x plus 2. Number 10. Limit x going to 2, 2x plus 4 to the power 1/3 minus 2 divided by x minus 2. All right. These are the questions we supposed to discuss under this theorem. Yes. Take the answers. Try the first one. Yes, first one now. X to the power 7 minus 128 over x minus 2. This I write like this. Limit x approaches to 2. X to the power 7 minus this 128 you can write as 2 to the power 7, no? 2 to the power 7 is 128, no? Yeah, divided by x minus 2. Now see whether this is available in accordance with our theorem. Yes. These two powers being equal. Once we ignore the powers, what we have x minus 2, that is at the denominator available. X going to 2 available and the limits. Then what is the answer? 7 comes before this 2. New power of 2 is what? 7 minus 1. Okay, right. 7 into 2 to the power 7 minus 1. 7 into 2 to the power 6. Right. Then do we multiply like this? 7 and 2 we multiply and then we take 6 power? No. First find 2 to the power 6 and multiply that by 7. 7 multiplied by 2 to the power 6 is 64. No? 448, no? Right. Take number 2. Limit x approaches to 2, x cube minus 8 upon x squared minus 4. Hmm? Hmm. Right. Limit. I first write like this, people. Look at this. This x cube minus 8, I write like this. Here. X cube minus 2 to the power 3. This x squared minus 4, I write like this. 1 over x squared minus 2 squared. Here we have product. Then really this right hand side is this, no? Yes. No doubt. Same thing, no? If I write here 1 into this, same thing come in here, this and this is coming here, same thing this. Yeah. Now I do like this here. People, I write here x minus 2. Then below this level, here I write x minus 2. Does this initial expression change? No reason. This x minus 2 is above this line, this one. This is below this line, this and this will cancel. Still the same. Understand? Right? This x minus 2 is really, this is one below this line. That means here, this level is this x minus 2 available. Once I bring here, this one here, this and this you can cancel now. Then this and this, that is this one available, no? Right. Now we must take limit of this, but this time this whole thing is equal to this. We take limit for this separately and for this separately like this. Right. Now that theorem is formed at two places. Right? What's the answer here? 3 comes before 2 to the power 3 minus 1 here into 1 over 2 comes before 2 to the power 2 minus 1 here. The theorem is formed at two places. Now you can take the answer. Right. Yes, here x cube minus 8 you can write like this. X squared minus 4 I can write like this. Denominator. Okay. I wrote below this x minus 2 and here also I wrote x minus 2. No change for the initial expression because this x minus 2 will cancel with this. We are having still what? This divided by this, that means this. Why we divide like this x minus 2 and multiply by x minus 2? In order to form this theorem. And the single limit in the left hand side, I applied for this and this separate. Then this theorem has formed here and here. Now result of the theorem, now you can apply here and here separately now. That's... What is the answer here? 3 comes before 2 to the power 3 minus 1 into, here we have 1 over, this figure available below the line, 1 over, right? 2 comes before 2 to the power 2 minus 1 like this. All right, now simplify this. 3, 2, 3 minus 1 is squared, 2 squared, 2 squared, right? We have into 1 over 2 to the power 2 minus 1 is 2 to the power 1, 2. Then we get the answer as 3. Answer is 3. Right? Here 2 squared 4, 2 and 2 make 4. 2 and 4 we can cancel down. We get 3. Third one take. Limit x approaches to minus 2. X to the power 5 plus 32 divided by x plus 2. Hmm? Hmm? How to take this now? I can write this way. See whether I am correct. Limit x approaches to minus 2. I write this plus 32 like this, minus 32 like this. This plus 32, I write like this. Minus plus 2. This x plus 2, I write x minus 2 like this. Any question? No. Next line. Limit x approaches minus 2. X to the power 5 minus. This minus 32, we can write minus 2 to the power 5. Multiply minus 2 5 times and take the answer. What do you get? We get minus 2, we write 5 times and we multiply. Minus sign when you multiply 5 times, answer is minus. 2 to the power 5 is 32. This is coming, no? Here, x minus 2. See, now everything okay according to what? This theorem, no? Once you ignore this 5, x minus 2, here we have. Under limit, this x should go to minus 2. That also available here. Look at this. All right. Now we can apply the theorem. Yes or no? Yes. Apply. What do you get there? In this comes before this. 5 into minus 2. It comes before minus 2. Subtract 1 from this. 5 minus 1. 5 into minus 2 power 4. Minus 2 power 4, 16. 16 into 5 is 80. 80. Is the answer. What's wrong? What's wrong? എല്ലാം സാറി We'll count the last one, number 4. Try to get this last one. This one. Take the fourth one. Fourth one, right? Question number 10 today, then this one. Right. Limit x approaches to 2. This 2x plus 4 to the power 1/3 minus 2 divided by x minus 2. This way, right? Right. Now, 2x plus 4, 1/3. This 2 I can write cube root of 8. What is the cube root of 8? 2, no? 2. Then this 2 I write 8 to the power 1/3. Now, this denominator, x and this minus 2, both I multiply by 2. Then we get 2x minus 2. Then this given original expression will change, no? Why? Multiplying this x and 2 by 2 means this given expression we have divided by 2, no? Okay. Then to balance that, I multiply by 2 like this. Then the initial one, does it change? 2x plus 4 minus 2, x minus 2. Does it change, 2 and this 2 take out as common factor. Cancel down that 2 with this 2. Here we have x minus 4 years. ඒක නේද බල බල හිටියේ. ඒක තමයි මට තේරුණා හොරෙන් බලනකොට. එයා මොකද අනේ කරන්නේ වගේ බැලුවේ. 2x minus 4. නේද? වෙන්න පේන. 2x minus 4. I just wanted whether you keep the attention on this. Good. 2x minus 4. Right. Then take 2 out and cancel down with this 2. Then we have x minus 2, the same thing, no? Right. Now, limit x going to 2. Next line, I do like this. Because this 2 is a constant. X going to 2. X is a certain variable. It takes values up to 2. But this 2 is a figure on the real number which is forever same. Nobody can change that 2, its size or anything, the place on the real number line. Therefore, though x goes to 2, this 2 doesn't change. It's a constant. Therefore, no effect going this x to 2 for this 2. We can take this 2 away from this limit. No change. No? Right? As x going to 2, the expressions which can change are the ones involving x only. Anything other than that won't change due to x going to 2. This 2 is a fixed value on the real number line. Forever same, no? Like a true love. Forever the same. Never change. When something happens around us, x going to 2, we never change. එමනේ? පිවිතුරු ආදරේ වගේ කවදාවත් වෙනස් වෙන්නේ. Right. There are people you can take this 2 out like this. It's going to like this. Right. Now, 2x plus 4 to the power 1/3 minus 8 to the power 1/3. Right. Now, this denominator, I must have 2x minus 4, no? I write that like this. 2x plus 4 minus 8, I write. Then by this, do we get this really? Yes, it is. Plus 4 minus 8 is minus 4 coming. That's fine. Now you can see here, once you ignore this power and this power, what you get? This and this, no? That is available denominator. Partially, we are okay with the theorem now. What are the rest thing we have to form in order to use that theorem we learned? This limit part, no? The limit part we told what? This thing should go to what? 8. No? Huh? We told once you ignore this power and this power, what you have, that should be at the denominator. That is already okay now. Then to get use of this theorem, now the one thing we have to form there. What is that? Under this limit, not x going to 2, we must have what? 2x plus 4 should go to what? 8. If we can form that one, directly now we can use what? The theorem. But people, see here, once you very carefully look at this expression, I write this one here, but as x going to 2, what happened to this 2x plus 4? 2x plus 4 limit, right? X going to 2, this 6. This 6 only here we have, x going to 2. Once you put values for this 6 which are very close to 2, tell me what happened to this? 2x plus 4 going close to what? 8, no? 8, no? Yes. Then people, in this statement, that clearly contains x going to 2 means what? 2x plus 4 going to what? 8, no? Put like 1.9 here. 4 and 7.9, something like we get, no? Then going to what? Put just 2 here. 2 and 2, 4. 4 plus 4 is 8 coming, no? That means x going to 2 really means what? 2x plus 4 going to what? 8. Therefore, in the next line, of course, this limit x going to 2, we can replace by what? 2x plus 4 going to what? 8. Understand? This contains what? 2x plus 4 going to 8. Now everything okay according to what? Theorem. Now we can apply theorem. No? Okay. Therefore, we can write like this. 2 times lim 2x plus 4, right? 8. 2x plus 4 to the power 1/3 minus 8 to the power 1/3. 2x plus 4 minus 8. Right. Now correct, no? Everything now satisfied with the theorem we learned. Yeah. This power, when you ignore this thing we have here, under that limit, this goes to 8 here. Then what's the answer? 1/3 comes before 8 to the power what? 1/3 minus 1. Understand? Think. Where are the doubts? X going to 2. This x means this x here. X डाल लो 2 क्लोज कर लेगा. 2. This x value going to know. Guess the value for x. Put 1.5 like this. 2 into 1.5 and 4. And put another one for this x 1.9. 2 into 1.9 plus 4. and see all those values, you can see what those values will go into 8, no? That's what is it. 2x plus 4, because we need that here to apply what our theorem. This should go to this 8, no? Therefore, this limit x going to 2 should not be here, but we should have this there. That's why we search that. Understand? Yes. Then everything is okay, no? Now we can apply. 1/3 comes before 8, 1/3 minus 1. What's the answer? Minus 2/3 here, no? 1/3 into 8 to the power minus 2/3. All right, we can simplify that furthermore. One third, this 8 to the power minus 2/3 we take to denominator. Then what happens? This power will be plus. Okay. 1 over 8 to the power plus 2/3 like this. 1/3, 1 over this 8 I can write 2 to the power 3, that to the power 2/3. 1/3, 1 over. How to simplify here, people? This inner power and the outer power we have to multiply. 3 and 3 will cancel. We get 2 squared. Then we get here 4, here 3. Answer is 1 upon 12. 1 over 12 is the answer. Right, no? I missed something. What's that? This 2, this 2, I missed, no? Right. Don't miss that. Once you miss that, you will be Mrs. 1 upon 6. That 2 should also be here, no? Right. Okay, now let's see when this x goes to infinity, how to evaluate some limiting questions, right? Okay. Okay, right. We'll write another set of questions. Correct, no? This 2 must be there, no? I forget that to write here. So that 2 should come everywhere there in 1 over 6. Right. Our next questions are these. 11. Limit x approaches to infinity. 4x squared plus 5x plus 6. 3x squared plus 4x plus 5. Number 12. Our limit x going to infinity. 2x minus 3. 3x plus 5. 4x minus 6. Over 3x cubed plus x minus 1. 13. Our limit x approaches to infinity. X minus square root x squared plus x. Number 14, the last one. Head of this all. Limit x approaches to infinity. Square root of x squared minus 8x plus x. Right, these are. But x going to infinity. What is infinity, people? The huge possible value. Biggest number. Where is this infinity? On the number line. The most right corner of the number line. Where is it? Where is it? Close to our house? Nobody can find the place of plus infinity on the number line. So big. Right. What if people, once I put directly infinity for the places of x in this expression? Let's see. I am going to put infinity for x. 4 into infinity squared. 5 into infinity plus 6. Divided by 3 into infinity squared. 4 into infinity plus 5. Infinity squared means infinity into infinity. What is that? Again infinity. ලොකු එකක් තව ලොකු එකකින් multiply කරනවා. ලොකු එකක් කියන්නේ. That again we multiply by 4. අම්බානක් ලොකුයි තවත් ලොකුයි. Infinity. Right. 5 into infinity, infinity plus 6. Right. Here also like that. Infinity. Infinity plus 5. Infinity plus infinity. 2 times infinity. That means again infinity. Infinity plus infinity is 2 times infinity. Again infinity. To that infinity we add 6. Again infinity. ලොකු එකට චූට්ටක් add කරනවා. Then numerator infinity. Similarly numerator infinity. What is infinity by infinity? Undefined form. Badune. Understand? Let's see in this case how to take the answer. People think like this. Now we divide 1 by 10. Answer is, 0.1. 1 by 100. Answer is, 0.01. You can see when this denominator increasing, what can we say about resulting answer? Decreasing. So if I take another one more, 1 over 1000, 0.00, right? 1 we get. Once the denominator is increasing, the answer, look at this, 0.1. I am going to mark the number line here, 0. This is 0.1, 1 over 10 here. 0.01 is on the left of here. 0.001 more closer to this 0, no? Then what can we say? When this denominator is increasing, the answer is going closer to what? 0. Then finally tell me, once this denominator goes to infinity, what can you say this number? That goes to what? 0. Understand? යට එක ලොකු වෙනකොට මොකද වෙන්නේ ළමයි? යට එක ලොකු වෙනවා. Then overall answer is going to 0. නේ? යට එක ලොකු කරලා බලන්න. මේ 1 over 10.1. 1 over 100.01. 1 over 1000.001. Once the derivative is going bigger values, the overall fractional answer going what? Closer to what? 0. Then once the denominator goes to infinity, what happens? This fraction will be what? 0. So therefore, people, when we evaluate this limit, what we do is this. First, among the x terms at the numerator, determine the highest x power. That highest x power take out from a bracket as common factor. Okay. Similarly, from the denominator, among the x terms, determine the highest x power. Take that highest x power out from the denominator. Then cancel down x letters. Thereafter substitute infinity for remaining x's in the remaining expression. Then you get the meaningful answer. That's the limiting value. Okay, right. Now I will take the first one, number 1. Right. 11th one. 4x squared plus 5x plus 6 is right. People now tell me, what is the highest power of numerator? X squared. Take x squared out. Take x squared out. Tell me what are the terms inside bracket we get? People remember, when you take something like this out from an expression, when you need to determine the terms in that expression, what you need to do is all the initial expression terms should be divided by the common factor you took out. Okay? When you take x squared out from these three terms, x squared is a common factor. Now the terms inside the bracket, when you need to write, what you need to do is all these original terms should be divided by this x squared and write the answers here. 4x squared divided by x squared. What do you get? 4, no? Right, 4 here. 5x divided by x squared. What do you get? 5 over x, no? 5 over x. 6 over x squared, this way we get. Right. Right. For this denominator also, you have to do that. Take x squared out. 3x squared, we have divided by x squared, we get 3. 4x, we have divided by x squared, we get 4 over x. 5, we have divided by x squared, we get 5 over x squared, like this. Okay. Now cancel down x powers from numerator and denominator. Until then, don't substitute for x the infinity. Now this is the place to substitute infinity for remaining x's, right? Here 4, 5 over infinity, 6 over infinity squared, 3 plus 4 over infinity, 5 over infinity squared. What is 5 over infinity? Here. Small number divided by huge number. Going to 0. No? Yes or no? Yeah, take a look. When you go to fraction, you see this is 0. This is also 0. This is 0. This is also going 0. Then denominator you have what? Numerator you have what? 4. Denominator you have 3. Answer is 4 by 3. Okay. Right. Next Saturday, if the Ramas are not falling on this next Saturday, we will keep the class, right? Ramzan sometimes Friday, no, Friday or Sunday. Right. Sorry. If Ramzan not coming to this next Saturday, we keep the class, huh? Right? Okay. Vanga. Right. Okay. Okay, now we come to number 2, second one. It is 12th one, limit x approaches 0, 2x minus 3, 3x plus 5, 4x minus 6, 3x cube minus plus 6 minus 1, right? Now, this how we do here. From this bracket, we take x out. From this bracket, we take x out. From this bracket, we take x out. Then here x, here x, here x. What is that? X cube. Right? Take x out from each bracket. From this denominator, from this expression, take x cube out and cancel down x cube and put x infinity. Right. X out from this, x out from this, x out from this, x cube. When you take x out from this and this both we have divided by x, we get 2 minus 3 over x. Here, 3 plus 5 over x. Here, 4 minus 6 over x. Here, take x cube out. Then all these 3 terms we have divided by x cube. Then this divided by x cube means 3. X divided by x cube means x squared. 1 divided by x cube means 1 of x cube. Now cancel down this x cube. Not put infinity for every x in the remaining expression. Right. 2 minus 3 over infinity this bracket. 3 plus 5 over infinity second bracket. 4 minus 6 over infinity next bracket. 3 over 1 over 3 plus 1 over infinity of x squared. Yes. This is 0, this is 0, this is 0. We get here 24 over 3. 24 over 3, that means 8. Right. It's okay. We take 13. Another one more. Limit x tends to infinity. X minus square root of x squared plus x. When we substitute infinity directly for x here, this is infinity minus inside the square root infinity squared plus infinity. Infinity squared is infinity plus infinity is infinity plus infinity to infinity, that means infinity. Root of infinity is infinity. Then we get this way. Infinity minus infinity. Infinity minus infinity has no meaning, undefined form. So therefore, in this case, to take the answer, multiply this by its conjugate and divide by conjugate and simplify. Multiply this by its conjugate and divide by conjugate. Right now here, what do you have? A minus B into A plus B. What is that? A squared minus B squared, no? Yes. Limit x goes to infinity. A minus B into A plus B means A squared minus B squared. A squared means x squared. Square of this going will eliminate x squared plus x divided by x plus root x squared plus numerator. This x squared minus x squared we can cancel it out. Okay, then we have minus 6. Right, people, now from this denominator we have to take x out. People remember like this. Here, suppose we have a root here, x squared and x4 sum we have here. Since x squared inside the root sign is common, I suppose to take x squared out. Okay. Remember, once you bring something out from a square root, its power should be divided by 2, right, outside the square root. Okay. Then, of course, once I take this x squared and here x squared out, when it comes, the 2 of we have divided by 2. Then what do you get there? Once you take this x squared out, it becomes 6. Now this x squared whole thing we took out. There we have 1. From x power 4, only x squared we took out. Now the x squared is there. That's how we write. Okay. Remember, when you take something out from the square root, once it comes out, its power should be divided by 2 and write. Okay. Like that, people, here, from this root sign, I suppose to take x squared out. Okay. Here we don't have x squared. Then what I do is this. Think, imagine now, I multiply this by x, divide by x. This x I multiply by x and meantime divide by x. Then this one change. X and x now, x squared. Divide by x only we have now. And now here we have x squared. Here we have now x squared. Take that x squared out. That becomes x. Now tell me, inside the root sign we have here now 1 plus here 1 over x. Is it clear? Correct, no? Yes, now write down that. X plus this a. Right. Now, from the denominator, this x and this x is common. Take that out. X you can now cancel. Now, this x and this x you can cancel and you get 1 here. Now we have 1 root 1 plus 1 over infinity minus 1 over 1 plus 1 minus half. Minus half, right? Right, no? Yes. Right now, yes. Right now, we'll come to next theorem. Now we are supposed to discuss questions involving trigonometry. Right. Write down subheading like this: trigonometric limits. Trigonometric limits. Trigonometric limits. There we have one theorem. We'll write the theorem. That theorem also is supposed to prove later. Right. Theorem, right. Theorem is this. When theta is measured in radians, you know what is meant by radians, and theta less than pi by 2 greater than 0. Okay, theta is in between 0 and 90. Okay, then limit theta goes to 0, sine theta divided by theta equals 1. Okay, equals 1 means what? Going to 1. We write that as equals 1, right? This theorem we prove later, right? Write down the theorem now. When theta is measured in radians and theta is in between 0 and 90, then limit theta going to 0, sine theta over theta equals 1. This theorem also we supposed to prove in the next classes, right? Right. We can write next note. Note is this. Note number 1. Limit theta going to 0 cos theta. Can remember the cos theta graph? Cos theta graph we learned in trigonometry. When theta equals 0, cos theta is 1, the graph was like this here. Here theta is 3. Right. Here, look at this. Now, this is the theta axis. Right. You can see angle 0 is exactly here. When we come along this angle axis to this point, this theta is coming to what? 0, no? The angle axis is theta axis, no? Theta angle coming 0. Right. This way also we can come to 0. Yeah. Okay. Once you come this way, we say what? Right limit. This way, left limit. You can see, once you come to this 0, from both ends, this height gives us what? This height gives us, at that angle, the value of cos value. Okay. You can see, once you come towards this 0, this height is gradually increases up to what? 1. Okay. From this end also, you can see that, no? When you go to 0, from the left of this angle 0, this height gives us the cos value of that corresponding angle. That means when we have this angle for our theta, then cos theta value is given by this height. Once you go towards this 0, angle 0, this height is increasing. Look at this here. Then tell me an answer for this. As theta going to 0, cos theta. Cos theta is what? Cos theta is 1, no? His height is 1. Okay. Right, no? Then we can use this one. Number 2, second note. I am going to write this way, people. Limit theta going to 0, tan theta by theta. Right? Okay. Now, I can write this tan theta. Tan theta I can write as sin theta divided by cos theta. And here we have theta. That theta I write as 1 over theta. Now I write this one like this. This theta I bring here like this. And this cos theta I write as 1 over cos theta. Okay. Now here we write limit theta 0. And for this we apply limit theta 0. By this theorem, this is 1. This is 1. As theta going to 0, we know cos theta is what? 1. Then here we get 1 over 1. Then what do you get there? 1 into 1 over 1 means 1. So therefore, as theta going to 0, tan theta also what? 1. Okay. But this result don't use directly. You must use that in this way, right? But sometimes when we take the answer for our convenience, without writing like this, we take the answer like this. But at the examination or wherever, don't use this directly. Okay? All right. Write down the note number 1 and note number 2. First theorem write down, then note number 1 and note number 2. Right now? Right. Now we'll take down some questions. Next day, we start the Copeland forces first theories. In that also, first 4 hours we do Copeland forces, most important theories we discuss. Thereafter, we go the 2 lessons. And meantime, I told you that weekly paper I will give you. Most of the time, next day I will give you that. 3 questions, we can do them. You can do them as homework. I'll discuss them, 3 or 4 questions in the paper, right? Right. Right. Now, take your mind another 5 months for the 2026 students exam. After that, the A-level exam papers will be set for you, right? So therefore, now we gradually come in towards that critical moment. So therefore, we have to work harder, having a certain responsibility of mind. Yes. Right. So these are the questions. Number 15, limit x going to 0, x cos 6 plus sin x over x squared plus tan x. Number 16. One minus cos 2x plus tan squared x over x sin x. Number 17. limit x tends to 0, 1 minus cos 6 over x sin x. Number 18, limit x going to 0, sin 2x plus sin 6x divided by sin 5x minus sin 3x. These 4 questions we'll do first. First one. X cos x plus sin x divided by x squared plus tan x. Right, people, now we can't give exactly this is the method you must use to take the answer when you are given this way limit question. That depends on the question. So therefore, best thing is not to ask it like that. The common method will do more sums. Okay. So from each sum, you will get something. You will learn something and remember them and apply wherever you do a question. Okay. So therefore, we'll do some sums today and next day also I'll give you a tutorial. You can try those sums. That's how people to overcome these issues of getting the answers for the limits. Otherwise, there is no common standard methods to get the answers. If so, all people will do maths and then all people will be genius. No, that is not true. No, right? So that situation, if somebody can manage, right? So he will win the game. Okay. So therefore, doing more sums is the only option to get rid of these issues when you find difficulties in working out questions, right? Okay. Today we will discuss some questions only, right? Next day after getting the tutorial, you can try them as homework, right? In this case, people, I give an approach like this. This is a fraction, no? This is a fraction. The numerator and denominator of this fraction we can divide by any value which is not equal to 0, right? The fraction won't change. Why is it important? The divisor should not be equal to 0. We know when we divide something by 0 like this, 2 over 0, what's the answer? What's the answer? Don't say infinity. No, not infinity. Infinity coming like this, people. We have this way, 2 over x, limit x going to 0. Right. Okay. This figure coming to 0. We told that x going to 0 doesn't mean what? X equals 0, no? We told. Limit x going to 0 doesn't mean x equals 0. Then what? This x takes what? Very closest values to what? 0, but it doesn't take 0. This situation never arrives. So people, we say what? See, this I take 2 over 0.1. What's the answer? 2. 2000. You can see what? When the denominator here going closer to 0, no? These figures are what? 0.1, 0.01, 0.001 are what? The values are going towards 0, no? That means when the denominator is going closer to 0, you can obviously see what this answers here. This answers what? Going to very huge values. Therefore, people, 2 upon x as limit x going to 0. This is going to very small values. Then this goes to what? Infinity. This is the one we define as infinity. But 2 upon 0 is what? 2 upon 0 is undefined. Don't see infinity, undefined. Understood? Okay? Right. Here, I divide both numerator and denominator by x. We know x is not equal to 0. Reason? We have x going to 0. X going to 0 doesn't mean x takes 0. So therefore, numerator and denominator we can divide by x. Understood? Let's see now what we get there. All right, divide this numerator and denominator both by x. Here we get cos x, no? Right, here we get sin x upon x. Here we get x squared. Divided by x means x. Here we get tan x over x. Okay. Now, the limit x going to 0, we can apply for each term separately like this. Limit x tends to 0, we can apply separately for each term at the numerator and denominator. Like this. Okay, now you can take the answer. What is this answer? Cos x going to 0. Cos x as limit x going to 0. What? 1. What is this? Sin x over x going to 0. Also 1. X going to 0, x here. What can say? This is 0, no? Why? Here x, that x going to 0, then this will be 0, no? Here, tan x over x going to 0. Today we learn now. 1, no? Right? We'll put that as 1. Tan x over x, tan theta over theta as 0 going to 0. Under that note, second note we learned, that's 1, no? Yes, right. Put that there. This is 1. This is also 1. This is 0. This is 1. Then the answer is 2. Answer is 2. Count number 16. Next one. One minus cos 2x plus tan squared x over x sin x. Cos 2x, to cancel this 1, you have 3 formulas for cos 2x. Of them, we have 1 minus 2 sin squared x. Can you remember this formula for cos 2x? There are 3 formulas for cos 2x now. What is first one? Cos squared x minus sin squared x. Second one, cos 2x equals 2 cos squared x minus 1. Third one, cos 2x equals 1 minus 2 sin squared x. We learned them. We use that cos 2x we are here, 1 minus 2 sin squared x. Right. Here is tan squared x. Right. I write that first like this. And x into sin x. Right. Once we remove the bracket by multiplying this minus sign, what happens, people? This one will be minus 1. These two we can cancel down. Minus minus plus 2 sin squared x. Tan squared x you can write as, people, sin squared x over cos squared x. This tan squared x I wrote. Divided by x into sin x. A limit x going to 0. This way. Right. Now, from this numerator, this sin squared x we can take out. Okay. Take this sin squared x out. Limit x tends to 0. We write taking this sin squared x out. within bracket we have 2 plus 1 over cos squared x. X into sin x. Tell me one simplification there. People, tell me one simplification there. 1 sin x, we can cancel down with this sin x of sin squared x. Remember to get 1 sin x here, no? Right. Don't take seriously. These questions are difficult. No, not difficult. First, once I do some questions, follow that. Remember that method, that techniques. They are try questions. Okay? Right. Don't go to decide at the very beginning. Okay. People, now, what I do is this next. Sin x multiplied by this thing divided by x. Here we have a product at the numerator that should be divided by x. Then by this x, do we need to divide this sin x and this both? No, only one term, either this or this, enough to divide by x. Then tell me, by this x, which term, this or this we divide? We'll divide this sin x. Why? We have a theorem sin x by x as exponent 0, 1. To use that, we will divide sin x by x. We'll keep the rest one aside. Okay, like this. Okay, no? Right, limit exponent 0. Sin x upon x. Right. Because the other one is here. For that, I apply limit separate like this. Okay, we have a product here, its limit. That is equal to product of the limits, right? Then apply that here, this way. Okay. Now people, you know what is this? This is 1. Okay. Sin x of x as exponent 0, 1. Tell me this. Right? What happened to this 2? Limit exponent 0. What happened to this 2 as exponent 0? 2 doesn't change. No? 2 doesn't change. Understand? 2 will be same to the bracket. Here, tell me, as exponent 0, put here 0. Cos 0 is 1. 1 squared is 1. 1 over 1. It is 1. Then 2 plus 1. Here we have 1. Then what do you get? Here 3, here 1. Product is 3. Correct, no? Yes. Okay, now take number 17, this. We'll take number 17 after this. Limit x going to 0. One minus cos x over x sin x. Right. Right. Substitute for this cos x in half angle formulae to cancel this 1. What are the three formulae for cos x in half? We learned in trigonometry. I told you trigonometry is so important throughout this course. What are the three formulae for cos x? Yeah, first one is cos squared x by 2 minus sin squared x by 2. Cos x. Cos squared x by 2 minus sin squared x by 2. So what is the next one? 2 cos squared x by 2 minus 1. What is the third one? 1 minus 2 sin squared x by 2. Substitute 1 to cancel down this 1. So then since here we have minus sign, the formula for cos x we must substitute should contain plus 1. That is nothing but this, no? Yes, all right. Limit x going to 0, 1 minus 2 sin by 2. Right. X times sin x. Tell me half angle formula for sin x. 2 sin x by 2 into cos x by 2, yes. 2 sin x by 2 into cos x by 2. Cos x by 2. Okay, now simplify this. Here remove bracket, 1 minus 1, 0 minus minus plus 2 sin squared x by 2 x into 2 sin x by 2 into cos x by 2. Okay, right. Tell me a simplification here. 1, 2 you can cancel down with this 2. 1 sin x by 2 term we can cancel down with this. Okay. Right. Next line, limit x going to 0. Here we have sin x by 2 at the numerator. Denominator we have x here and cos x by 2 here. I write them separately like this, x here into 1 over cos x by 2. Like this. Any question up to here? No. Okay. Now, can we apply that theorem here? X going to 0. Sin x by 2 divided by x. We can't. Reason? Remember the theorem. Theorem said this way. Sin theta upon theta, limit theta should be going to 0. Then only we can write this as 1. That means, people, here this angle should definitely be here. That angle only should go to 0 under limit here. Then only you can write 1. But here you have what, people? X by 2. But here we have x. Then to apply this theorem here also we have to have what? X divided by 2. Otherwise you can't. Yes. Then I can write like this it. Sin x by 2 divided by x only here we have. All right. People, now this x I divide by 2. To cancel down this 2, I write 2 here. Does it change? No. Neither. Divide kara, multiply kara. Not changing. Yes. Now, limit x going 0. People, now, this 2 I write where before taking before this. I write another one step after this now, like this. Right. And here, 1 over cos x by 2. Right. This way, okay. Now, think another one more there. Right. Take here this. We are given under this limit. Under this limit, we are given x going to 0, no? Right. I'll take some else for x. Here on the number line, we have 0, right? Yes. I take x is here 0.4. Next one, x 0.2. Next one, 0.1. These are the x values. These are the x values. Right. Now I am going to find x by 2 values. Right. X by 2 values means what? These x values we divide by 2. When x takes 0.4, what is x by 2? 0.4 divided by 2. What is that? 0.2. When x is 0.2, what is x by 2? 0.1. When x is 0.1, what is x by 2? 0.05. People, what can you say here? When x going to 0, x by 2, what? Here? Going to 0 more early, no? Understand? Neither. As x going to 0, x by 2 going to 0 more early. So therefore, people, here we have x going to 0, x going to 0. This x going to 0, I can write how? X by 2 going to 0. Understand? Then what I do is this. I take this 2 out. Right. Since it is at the denominator, when it comes out as half. Because it is constant. X going to 0 can't change its constant value. Now, limit x by 2 I write in place of this what? X. Why? As x going to 0 means what? Half of x also going to 0. That's the reason. Yes. Then, of course, we have the required form. Sin by 2 divided by x by 2. And here we apply limit x by 2 for this. Okay, now this is okay, no? The angle x by 2, here we have the same angle only going to 0. Then by applying that theorem, this is 1. This is 1. Right. What is this? 1 over here. X by 2 going to 0 means this is going to 0. Then cos 0 come in here. What is cos 0? 1. Then 1 over 1. Right? 1 over 1. Then the answer is what? Half. Answer is half. Okay, it's number 18. You can do as homework. Try that. We'll come another one set of questions. Okay, no? Yes. First, take down this way. Right? When x going to 0, people, any multiple of x also going to 0. Remember that. X by 2, x by 3, 2x, 3x, and so on. Right. Okay, now write down this set of questions. 19, this. Limit x tends to 1, 1 plus cos pi x, right? Over 1 minus x perfect squared. 20. Limit x going to pi. 1 plus cos 6 divided by pi minus x perfect square. 21. Limit x going to 0. 1 plus x root minus 1 minus x root divided by sine inverse x. This. Right. We'll see how to take the answers of these. Number 19. Limit x going to 1 plus cos pi x divided by 1 minus x perfect square. Right. Now, when we evaluate some limits questions, sometimes for our convenience of evaluating, we use a substitution, right? Okay, I am going to use a substitution in this case, right? Don't worry about this method, right? So this is the first time you learn, therefore don't worry. First of all, identify, understand, catch this method. Then remember that. And when you work out questions, try to apply them one by one. That's how we learn. Otherwise, don't go think, we don't know, it is very difficult. How do we decide like that? Don't take unnecessary things. The people first understanding this and keep in their mind, once they can apply wherever they find this kind of questions, they will win the game. Otherwise, don't take unnecessary things to your mind, right? Because there is no common standard method to work out all the questions. If so, all will do mathematics and there will be huge engineers in the world. Understand? Distinguish each type from other and remember that and apply wherever you find that. That's all. That's what we call learning. We also learn like that. Right? Nowadays also, when we were learning, we also expected this way, question by question, we have to apply different method. Give us a common method. No, such common methods are not available. Finally, only we understood. Once we expect this way, a common method, we can't do this thing. Then we also finally adapted to what? For one question, learn that, remember the method. Another question, learn that, remember the method, and apply that. So there are limited ways of working out questions. That is possible, therefore. When you take the answer for a limit question, there are a limited number of techniques, right, of getting the answers. If you can remember them, that's all. That's the only option. Other than that, don't think anything. Right. People, in this case, I take this way. I use a substitution theta as 1 minus x. Right? Now, our given variable is x. Now, after this moment, we are going to use the new variable theta. Given variable x, its limit going to 1. Now, we have to convert the limit x going to 1 for the new variable theta. That's the first thing you have to do whenever you apply a substitution. Right? This says people x going to 1. That means here we have x, no, this comes to 1. Then 1 minus 1 is what? 0. That says what? When x going to 1, this is 1, 1 minus 1, 0, theta going to 0. You have to find the new limit of the new variable. Okay? Then we write it how like this? As lim x going to 1. What can we say? Limit theta going to what? 0. Understood? That's what you must do first. Right. Now we'll start the question, this one. Right. Okay. Then we write like this. Limit x going to 1. The given question is this. 1 plus cos 5 times x over 1 minus x perfect squared. This is a given question, right? Now we are going to evaluate that through this substitution. All right. First thing is the found theta limit as x going to 1, we found limit theta going to 0. Then this one on the right hand side we write as what? Theta going to 0 limit, because we supposed to write the right hand side now in terms of theta. That's why. Then we write limit theta going to 0. All right. Now every x here, now we must convert to what? Theta, because our new variable is theta. Using theta only, now we are supposed to work out the question next part. Okay. Then 1 plus cos phi. We have x here. Cos phi x. See what is x here? 1 minus x is theta. Subject x, bring this x here. Bring this theta here. What is x? X is 1 minus theta. Understand? Put here 4x 1 minus theta. Right. Now people, here 1 minus x. 1 minus x is theta. Then what is this? Theta squared. Right. Okay. Now you can see completely the given question in terms of x. Now we have in terms of theta. That's fine. Now we'll do rest part of the question using the theta. Understand? All right. Come to that now. Yes, now let's see how to do this. Limit theta going to 0 here. People, I bring this pi inside. Pi into 1 is pi. Pi into theta is pi theta. Right? Like this. Right? 1 plus cos minus pi theta. Divided by, okay. Right. Usually what is pi in degrees? 180, no? Then this cos pi minus pi theta. This pi we assume as 180. Here pi theta. What are the actual answers of pi in radians? 22/7. This is now an angle. This one we take as 180. This pi theta we assume as angle in radians. Right? Then I'll take one single angle for this pi theta like alpha. Then this takes the form what? Cos 180 minus alpha. Tell me what is cos 180 minus alpha? What is cos 180 minus alpha? Minus cos alpha. Second quadrant cos is negative, no? Then tell me an answer for this. Cos pi minus pi theta is what? Minus cos what? Pi theta. Understand? Yes. Right. Write of that now. Limit theta going to 0, 1 minus cos pi theta divided by theta squared. Okay. Now write down this cos pi theta using half angle formula to cancel down this one. Tell me half angle formula for cos theta in terms of sine. We know cos theta we wrote 1 minus 2 sine squared theta by 2. Right. So like that, tell me how to write this. How to write this? Right. This one you can write how 1 minus within bracket 1 minus 2 sine squared. What? This angle should be divided by 2, no? According to this formula. Huh? This angle divided by 2. What should be there? Pi theta divided by 2. Right. This is an angle now. Theta square. Right. Now remove the bracket. Remove the bracket by multiply minus sign. Minus 1, no? That you can cancel down with this plus 1. This minus and this minus make plus. Right. Then we get this. Limit theta going to 0. 2 sine squared pi theta divided by 2 divided by theta squared. This is what we have now. Right, no? Now tell me a method to evaluate this. Right. People, I write it like this now. Same thing only I am writing now. 2, yes. Third, pi theta divided by 2. Here, right? We have this. We have theta squared. Right. Right. Okay. Doyan the bed. Dinan doyano. Well. Pai padi thattu dan lang ni kan. Doyano gode. Thattu dan. Narak thame ko thattu dan. Eso thagga. Tappe. Right. People, now I write here pi squared. Then the expression will change, no? To keep the expression at the initial value, this pi squared, I divide by, no, I write here pi squared. This and this will cancel. Nothing will happen there. Okay. And I divide this by 4. 4 I write as 2 squared. To cancel down this 4, I write 4 here. Then this 4 and this 4 will cancel, but that 4 I write here. Now you can very clearly see I am going to form what? That sine theta by theta form. Right. Now 2 pi squared over 4. This pi means 20 over 7 a real number. Then this whole thing is what? Whole thing is a constant. That constant doesn't change though this theta going to 0. Furthermore, this 2 and this 4 we can cancel down. Here we have 2. Then we have pi squared over 2. That pi squared over 2 is a constant. It doesn't change though this theta going to 0. Neither. අල්ලපු ගෙදර නෝනයි මහත්තයයි රණ්ඩුනා කියලා අපට බලපානවද? බලපාන්නේ නැහැ. බලපානවා සම්බන්ධයක් තියෙනවා නම් මේ ගෙදර මහත්තයාට යත් එක්ක. Like that, people, theta going to 0 doesn't anyway affect what? Constants. නේද? අල්ලපු ගෙදර දින රණ්ඩු වෙනවා නම් මේ ගෙදර මහත්තයා තරහ එනවා නම් පොඩ්ඩක් හිතන්න ඕනේ. මොකද ඒ නෝනට පුදුම ආදරයක් ඇති මේ මහත්තයා. ඒ නිසා පොඩ්ඩක් වෙනස් වෙනවා. එහෙම නේද? අන්න දන්න කට්ටිය. එහෙමද? දන්නේ. Right. හරි. ළමයි get by to take out. Right. Our limit theta going to 0. Right. This one you can write like this, no, people, here. pi theta by 2 perfect square. We can write this one, right? Sine squared pi theta by 2 divided by here pi theta by 2 perfect square. Right? Now here we have numerator perfect square, denominator also perfect square we have. That perfect squares you can write as single perfect square in the next line like this. Here pi squared by 2 limit theta going to 0. This I can write sine pi theta by 2 whole thing divided by pi theta by 2, right? Whole thing to the power 2, like this. Now see what has happened. We have what? Sine pi theta by 2 divided by pi theta by 2. This angle available here. Okay? It is now, according to that theorem now, sine angle divided by same angle. But this same angle should go to 0 under this limit. But we have only theta. Only theta going to 0. People, this pi theta by 2 means what here? Pi theta by 2 is really pi divided by 2 into theta, no? This pi theta by 2 mean you can write pi theta by 2 as how? Pi divided by 2 multiplied by theta, no? Now see here, this theta going to 0. Once this is going to 0, what can you say about this product? This product also going to 0. That means what? Pi theta by 2 also going to 0. Earlier I told you x going to 0, half of x also going to 0. That means when something is going to 0, any multiple of that also going to what? 0. Then I can write the next line how? In place of this theta going to 0, I can write what? Pi theta by 2 also going to 0. And this limit, then we can apply inside this bracket. Okay, inside this bracket. Then you get sine theta by theta, theta going to 0, that's going to be 1, 1 squared is 1 into pi squared by 2, answer is pi squared by 2. Understand? Okay, all right. Now hereinafter people, if you take for this one, answer as 1, you get full marks. But as this is the first question, we will write entire thing and take the answer, right? Okay. Then we have pi squared by 2. You know, theta going to 0 means what? Pi theta by 2 also going to 0. Neither am I. Yes, right. Then we can take this inside the bracket. Like this. Our limit pi theta by 2, 0, going to 0. Sine pi theta by 2 divided by pi theta by 2. It's perfect square. All right. Now, okay, people here, pi squared by 2. No? Okay. What is this? Sine angle divided by same angle going to 0. Inside the bracket, this is 1. 1 squared is 1. Then we get what? Pi squared by 2 into 1. This is nothing but pi squared by 2. This is how we take that answer. Don't worry about the method. When you do another 2, 3 questions, this will be okay. In the morning when you come to the class, you didn't know anything about limit, no? Now, what is the situation? Now you know a little bit about limit, no? Like that, these questions, if you find little bit inconvenience at the beginning, once you do some more sums, it will be okay, right? Only thing is, always think positively. Don't think that this is difficult, I can't understand this one, this will be difficult and so on. Don't bring unnecessary things to your mind. They retard. Always try to catch like this. One by one, I must learn. Otherwise, of course, you can't learn, right? You can't study. Right. People, now the 21st one, I'll give the hint to do as homework because before ending the class today, I must discuss another one more. That is the exponential function limits. That's the end of the limits. Right. I'll give the hint of getting the answer for the 21st question. Right? Right. Do this as homework this way. Here, limit x go to 0, 1 plus x root 1 minus 6 divided by sine inverse 6. Right? Okay. Separate this way. 1 plus 6 minus 1 minus 6. Right? Into 1 over sine inverse 6. Shall we do that then? Otherwise, you won't do this. I'll take on the 5 minutes. We'll do this. Take. Come to this. Take 21 also. Limit x going 0. I write this one this way now. 1 plus x root minus 1 minus x root. This sine inverse 6 I write as 1 of sine inverse 6. This way, right? This way I write. Okay. You know, people, once we evaluate this kind of thing, in the morning we did what? We multiplied by the reciprocal of this, or reciprocal conjugate of this. Right? Then we multiply mean times same conjugate. That's the first line. Do that now. Limit. Multiply by the conjugate of this. And mean time divide by the same conjugate. One over sine inverse 6. Okay, right. Right. Tell me what is the answer here? This into this means what? Square of this minus square of this, no? Right? We can write. What do you get there? Square of this means 1 plus 6 minus 1 minus 6. Divide by this. 1 plus x root plus 1 minus x root. Here 1 over sine inverse 6. People, this 1 here, we can cancel down with this 1 here. Right? Yes. Here minus minus plus. x plus x is 2x. Divide by this now. Limit x going 0, not theta. X going 0. Right. This we have. Right. This is what we have. Now, this is what we do next, people. Right. This 2 is a constant. Though this x equal to 0, 2 doesn't change. Neither. Neither. Right. We can take this 2 here. This x I write where? Here. And this limit x point 0 I apply for this and this separately. That we do next. Right. Okay. Take this 2 away. Limit x going 0. 1 upon 1 plus x root plus root of 1 minus x. And that limit x going 0, I apply, taking this x here, x over sine inverse x like this. Right? People, now you can take the answer for this. Right? The back row students next time should come to the forward, the front seats. The last row, 2 students should come to the front seat next year. Put x0 here and here. What do you get? When you put x0, this is root 1 plus this is root 1. Root 1 is 1. 1 plus 1. 2, no? 1 over 2. Here also we have 2. 2 times 1 over 2. A limit x going to 0. This we have. X upon sine inverse x. Right. 2 and 2 we can cancel down. We have this now. Right, nice. X over sine inverse x. Right. This only now we have to evaluate. Right now? X over sine inverse x. People, now sine inverse something gives us what? Angle, no? In trigonometry we learned. See here. Sine pi by 6 means sine 30, half. How to subject this pi by 6? Sine inverse half like this. Then what is this sine inverse x? Should be an angle, no? Should be an angle, therefore. Then I take sine inverse x as theta. Let theta equals sine inverse x. That means this. Take this inverse x to this side. Sine inverse, not sine inverse x, sine inverse to this side. We get sine theta. This gives us what? Sine theta equals x. Then you can write this how? This x means what? Sine theta. For this place you can put, because x is sine theta, no? This is sine theta. What is sine inverse x? Sine inverse x is theta. Okay. Right. Then we can write it like this. Therefore, right, this limit x going to 0 I write later. I substitute for this x. What is x? X is sine theta. Divide by sine inverse x. Sine inverse x is theta. Here we have theta. Now we must write. Now you can see, people, new question we have in terms of theta. Really, here we have used a substitution, no? Yes. Now tell me, theta should go to what here? See here, we have x going to 0, no? Yes. Where is x? Here we have x. X going to 0 means this will be coming to 0. Sin theta is equal to 0, we get, no? Sin theta equals 0 means theta equals 0, no? I repeat that again. X going 0, no? Here we have x. This place will be finally 0, no? Sin theta equals 0, we get, no? Sin angle 0, we get. For what angle sin becomes 0? 0, no? That means when x going to 0, this is 0. Sin theta equals 0 means theta 0. That means what? X going to 0, we can write as how? Theta going to 0. Understand? Then here we write this as theta going to 0. Now, to the whole question, what has happened? Now we have what? Limit theta going to 0, sin theta over theta. What is that? 1. Then final answer is what? 1. Okay. This is how we take the answer. Yes or no? Trigonometric knowledge we need. I told you, no. Trigonometry is the backbone of the combined maths. Right. You can remember, we told last week that we are going to stop the class today at 12:30, no? No, then? Then you absent last week. Then you didn't hear me. I told at 12:30 only we finish the class. Yes or no? Yes, no? Yes. Those girls are in the class. You were here. We told you. Right. Now 11:45. The last part we do. No, we told we stop the class at 12:15. Yes. Right. Going one step forward, then coming back. 2 steps forward, then coming one back. Then we can settle everything. 12:30 is the issue. 12:15 now, okay. Right. Write down. Next one. Write down limits with exponential functions. Exponential function. Limits. Exponential function. Right. Okay. Now we define the exponential function like this. Write down like this. The exponential function is given by y equals ex. Y equals ex. Where ex, people, this ex we define. This is very important. This is the very first time we learn about ex. Right. We define ex like this. Plus x over 1 factorial. Next one, x squared over 2 factorial plus x cubed over 3 factorial. Knows without n up to infinity. This is how we define the ex exponential function. Here this factorial mean, people, for example, 3 factorial mean, right? Starting from 3, subtracting 1 at a time, right? until we get 1. Subtract 1, 2. Subtract another 1, 1. Until we get 1. We multiply this way. That means, in other words, starting from 1 up to 3, we write and multiply. That is 4 factorial. Starting from 1, write all positive integers up to 4 and multiply. That is the 4 factorial. Right. This function is called as what? Exponential function. Understand? X is any real number. Okay? Write on that also. Now let's see first the value of x, value of e. Value of e can be found, put in x equals 0 on, x equals 1 on both sides, right? Right like this. The value of e. Put x equals 1 in left and right both. Yes. Right. Put x equals 1. Here we get e to the power 1. Put on the right hand side every x 1. 1 plus 1 over 1 factorial, 1 squared over 2 factorial, 1 cube over 3 factorial, 1 to the power 4 over 4 factorial, and so on. This way continues up to infinity. Now e. 1 plus 1 factorial means 1. 1 factorial is 1. 1 over 1. 1 squared is 1. 2 factorial means 2 into 1. 2. 1 cube is 1. 3 factorial means 3 into 2 into 1, 6. 1 to the power 4 is 1. 4 factorial means 4 into 3 into 2 into 1, 24. Like that we get people. Up to infinity. Okay. You can see here, this is 1, 2. This is half. Then up to here, from the beginning, the value is 2.5. Okay. E. This plus half is 2.5. After that, we have this way 1 over 6, 1 over 25, and so on. Another infinitely many terms available up to infinity. You can see once you move to right, since this denominator increasing rapidly, this overall fractional value is going to small values. From here up to all possible infinitely many terms when we add, and that time is 2.5 when we add up to 2 decimal places, we can find this value of e. It comes as 2.71. Then approximately the e has the value 2.71. Here up to here 2.5. The rest terms here up to infinity, since the denominators are rapidly increasing, the overall fraction value is rapidly decreasing towards 0. Once we add them all with this 2.5, finally up to 2 decimal places, we get the value of e as 2.71. So therefore, here enough to remember this e is approximately 2.71. Understand? Take down that 2. Right now? Right. Now, the next one. Graph of Ex, we'll draw that one also. graph of y equals ex. Graph of y equals ex, right now? We draw the graph of y equals ex like this. On this oxy plane only, we are supposed to draw this graph this way. This is the x-axis. This is the y-axis. This is negative x-axis. This is negative y-axis. Right. The important values we calculate like this. First one, when x equals 0, when x equals 0, I am going to find y value. Y equals Ex, no? We need to grow y equals Ex. I am going to find when x equals 0, what is y? Put that 0 where here. Y equals e to power 0. Power 0 of any number is what? 1. Okay. E means 2.71, no? 2.71 to power 0 is 1. Right, this is 1. Then what can you say? When x equals 0, y is 1. What do you mean by that? Graph passes through what? 0, 1 point. What is 0, 1 point? Graph cuts the y-axis at 0, 1. This is the point. Right. Second point, to draw the graph, we need this. Number 2. I am going to find the y value when x going to plus infinity. That means what? When we move along the x-axis to this n. Plus infinity means this n, no. We are supposed to find what? The y value. For that, we do like this. Y value when limit of x going to infinity of Ex. Right. Am I we need to find the y value when this x going to infinity. Right. What is E? 2.71. What is power now? Infinity. So you will get something like this, no? 2.71 is the value of E. That power is infinity. Right. Tell me, people, 2.71 to the power infinity. Take just 2 here. Without this 7.71. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. What can I say? 2, 4, 8, 16, 32. What happens? As the power increases, this value going to bigger values. When this is infinity, what can I say? It should go to infinity. Understand? Yes, right. Y should go to infinity. What do you mean by that? When we go along the x-axis, this right hand side, this y value of the graph should increase up to what? Infinity. That means what? The graph should be like this, no? No? When we go to right, this height what? Increases rapidly. Correct, no? Why? We got y going to plus infinity as we move along the x-axis to right. Now I supposed to continue this portion of the graph. Right? This point is what, people? 0, 1, no? Right. When we go to this direction means what? We are going to negative infinity along x-axis. And then I am going to calculate that too. Yes. Right. Number 3. Y value when limit of x going to negative infinity of Ex. Right. See what happens there? Right. This minus infinity, I here for this x. What do you get? E to power minus infinity. People, you can write e to power minus infinity as 1 over e to power plus infinity. Taking this to denominator, this one you can write as plus power. Earlier you notice e to power infinity is what? Here, 2.71 to power infinity means e to power infinity. We noticed that earlier as what? Infinity. Then this place now what? E to power infinity is what? Infinity. What is 1 over infinity? 1 over infinity means what? Very small value, what? 0. Understand? Correct, no? Yes. This is now 1 over infinity. 1 over infinity is y going to 0. That means what? When we go along this x-axis in the negative direction to this end, the y value of the graph is going to what? 0. That means what? Graph coming closer to what? Negative x-axis. Then only y becomes 0. Understand? So therefore, the graph of y equals ex is this. Hmm? You see, it never touches the negative x-axis and it coming closer and closer to the negative x-axis like this here. You see, coming closer to the negative x-axis. Understand? Don't touch the graph, touches the negative x-axis. It's coming closer. This point is 0, 1. This is y equals ex graph. Y equals ex graph is this. Right? Then you can see from negative infinity up to positive infinity, the graph is lying above the x-axis. That means what? Everywhere the y is what? Positive on the graph. When we move from negative end to positive end of the x-axis, everywhere y is what? Positive. Right. So then we can write that as a note. We have to write this all notes. These are very important in drawing this graph. Okay. Then you can write a note there. What's the note? Right? For all real values of x. For all real values of x, ex greater than 0. Ex greater than 0. People, what is ex? Ex means this, no? Ex is this. That is equal to y. Y means what? The height to this graph from x-axis. You can see when you walk along the x-axis from negative infinity up to this positive infinity, the height of this graph, it is y. You can see what? This y is what? Positive. This is positive, but that is equal to ex. Therefore, ex is positive for all x. That's what I wrote here. For all real values of x means what? From negative infinity up to positive infinity. Any x value, whenever you put here, this resulting answer is what? Positive. Ex is positive for all real values of x. That is very important when you work out questions in the future. Okay, then another two more we have discussed. There is a graph of y equals e to the power minus x and some limits involved in ex. I'll discuss that next week. Okay, bring this tutorial, not tutorial book to the class next week, right? Right, so then we'll come to the end of the today class.